In this question, we are given a table showing the probability distribution of numbers 1, 2, 3 on a biased spinner. So there are a few things that I want to go through here before we work out this question. So now the first thing is that um, a biased spinner is basically where some numbers are more likely to be rolled than others. So a biased spinner implies that some numbers um, right, some numbers um, are more likely to be rolled, more likely uh, to be rolled um, than others. Okay, and then the second thing is that, well, here we have a probability distribution of each of these numbers. Now, one thing you have to remember is that the sum of the probabilities of all events is equal to 1. So the sum of the probabilities of all events is equal to 1. So basically, and I'm going to use the second fact to work out the missing probability here. So the probability that the spinner will land on 3, if all these probabilities are to 1, it will be 1 minus 0.4 minus 0.35 minus 0.1, and this will be equal to 0.15. And then the next question is, Ryan is going to spin the spinner 80 times. So they want us to find an estimate of the number of times he should expect the spinner to land on a 2. So the number of times that we expect will be the probability of um, the spinner landing on a 2, which is 0.35. So that will be 0.35 multiplied by how many times uh, Ryan spins that spinner, which is 80 times, and that will be equal to 28. Okay, so we are going to apply the same ideas to work out number 10. Now, number 10, Becky has a biased six-sided dice. Now, a six-sided die just basically means that some numbers are more likely to be rolled than others. I've already explained that in question 9. So, and also in this probability distribution table, I also mentioned in question 9 that the sum of the probabilities of all events is equal to 1. So step 1, we're going to use that idea to find x. So step 1 is to find x. Now we know that all these probabilities are to 1, so 2x plus 0.18 plus 2x plus 3x plus 0.26 plus x is equal to 1. So all these probabilities are to 1. So basically 8x plus 0.44 is equal to 1, which implies that 8x will be equal to 0.56, which implies that x will be equal to 0.56 over 8. So x will be equal to 0.07. All right, so we have the value of x. And now we are ready to go to step 2. So step 2 is to find the probability that the dice lands on an even number. So step 2, find the probability that it lands um, on an even number. Okay, because that's what you're looking at. So, um, so even numbers, we have 2, we have 4, we have 6. Now, basically, what we'll have to do, because, well, we know what x is, so that means that this is 0.07, and 2x, that will be 0.14. Again, this will be 0.14. 3x, 3 multiplied by 0.07, that will be 0.21. So we know the probabilities of each outcome. So anyway, we can go ahead and work out the probability that it lands on an even number, and I've circled all even numbers. So this will be equal to 0.18 plus 0.21 plus 0.07, and that will give us 0.46. And then step 3, now we can finish off by finding the expected number of times it lands on an even number. So find the expected number of times it lands on an even number, lands on an even number. Okay, so that will be equal to, from step 2, the probability that lands on an even number is 0.46 multiplied by the number of times Becky throws the die, which is 200, and that will be equal to 92. So we expect this die to land on an even number 92 times.